Welcome friends, in this new video we see examples of improper integrals. In the previous video we have seen the definition of improper integral. Now here we see how to apply that definition by few examples. Suppose we want to integrate integration of 1 divided by x square between the limit 0 to 1. Here you can see that this integral has infinite singularity at point x equal to 0, and by definition we write it as limit lambda tends to 0 from right, and here 0 plus lambda 1 divided by x square into dx equal to limit lambda tends to 0 from right integration lambda to 1 divided by x square into dx. Now in this new range you can see that the infinite singularity is removed. Now integration of 1 divided by x square is minus 1 divided by x, and this is between the limit lambda to 1 limit lambda tends to 0 from right equal to limit lambda tends to 0 from right upper limit minus 1 minus minus plus 1 divided by lambda, and as lambda tends to 0, 1 divided by lambda tends to infinity, and therefore this limit will be infinite. As it is an infinity, the integration is divergent, it is not an convergent integral. Let us integrate one more example, 1 divided by under root of 1 minus x square into dx between the limit 0 to 1. Here the right hand side a b, that is x b equal to 1, is of point of infinite discontinuity. So we write it as limit mu tends to 0 from right 0 to 1 minus mu 1 divided by under root of 1 minus x into dx equal to limit mu tends to 0 from right integration of 1 divided by under root of 1 minus x, this will be minus 2 into under root of 1 minus x between the limit 0 to 1 minus mu. So if we take the derivative of this, you can see that this is 1 divided by 2 under root of 1 minus x into minus 1. Now at upper limit mu tends to 0 from right, we are not applying the limit now, minus 2 into upper limit 1 minus under root of this 1 minus mu, and minus at 0, this is 1 minus 0. Okay, this is both terms are in root. Limit mu tends to 0 from right minus 2 into minus 1 will be cancel and minus minus become plus. So here this is minus mu and under root of 1 is 1. Okay, as mu tends to 0, this root term will be 0 and we get minus 2 into minus 1 equal to 2. This is an finite term, and therefore in limit of this is exist, and there hence limit of this integral is 2. Okay. Now we consider another improper integral having discontinuity at both the end, dx divided by 2x minus x square. When we put x equal to 0, we have infinite discontinuity. When we put x equal to 2, 2 into 2, 4, 4 minus 4, 0. So both this integral have infinite discontinuity. Therefore, by definition we divide this range as 0 to 2 contain and point 1. So we divide this range from 0 to 1 and 1 to 2. dx divided by x into 2 minus x, dx divided by plus dx divided by x into 2 minus x. Now the first integral, you can see that it has infinite discontinuity at the left end, while the second integral have infinite discontinuity at right end. Therefore, we apply the definition of left hand. That means we consider here mu tends to 0 from right, integration mu 1 dx divided by x into 2 minus x plus limit lambda tends to 0 from right, integration 1 to 2 minus lambda dx divided by x into 2 minus x. Here now first let us apply the partial fraction terms. X into 2 minus x equal to, we write it as 1 divided by x plus b divided by 2 minus x equal to a into 2 minus x plus b into x divided by x into 2 minus x. Now 1 is equal to a into 2 minus x plus b into x. To find the values of a and b, let us put here x is equal to 0. When we put x equal to 0, we get 2a is equal to 1 and a equal to 1 divided by 2. Again, let us put this value as x is equal to 2, so that the first term will be vanish and we get 2 into b, and that means we have now b is equal to 1 divided by 2. So the integral terms dx divided by x into 2 minus x, this will be integration of 1 by 2 divided by x plus 1 by 2 divided by 2 minus x into dx, and 1 by 2 common, we can take 1 by 2 common. Integration of 1 by x, integration of 1 by x is a log x, and minus we have log of 2 minus x equal to 1 divided by 2 into log of x divided by 2 minus x. So this is the value of the integration. Let us put this value directly in this integration, in the two part of this integration, and apply the limit. This will be a limit mu tends to 0 from right, and the 1 by 2 log of x divided by 2 minus x plus limit lambda tends to 0 here from mu to 1, and lambda tends to 0 1 by 2 into log of x divided by 2 minus x between the limit 1 to 2 minus lambda. Substituting the upper limit and lower limit value, equal to limit mu tends to 0 from right 1 by 2 into upper limit at x equal to 1, we have 1 divided by 1, log of 1 is 0, and hence minus log of mu divided by 2 minus mu, plus limit lambda tends to 0 from right 1 by 2 into at upper limit log of 2 minus lambda divided by 2 minus 2 minus lambda, 2 get cancel and minus will be plus, and at lower limit we have 0. Okay, now you can see that in the here as mu tends to 0, this value mu between 0 to 1, and in between 0 to 1 log value is infinity. Here also we have this value becomes in lies in between 0 and 1, as this will be 2 divided by lambda. Okay, so and lambda tends to 0, so this becomes lambda tends to 0, that means 2 divided by lambda, this becomes infinity, and log of infinity is again infinity. So this is infinity, both are infinite value, and we have infinite, and therefore this integral 0 to 2 dx divided by 2x minus x square is divergent. It is not an convergent integral. So friend, we have seen three examples, one from one which having infinite discontinuity at left hand, one having infinite discontinuity at right hand, and one having infinite discontinuity at both the end, right and left. And we have seen how to apply the definition of improper integral to evaluate these functions or integrations having infinite discontinuity. I hope you have enjoyed this. Thank you for watching video.